The sky doesn't rush, it waits. Night after night, it stretches above us, calm, familiar, almost kind. Stars hold their places, planets follow their paths. Everything moves the way it's supposed to. That's why this story doesn't begin with panic. It begins with patience. For months, astronomers around the world are watching a small, quiet object drifting along the ecliptic. Nothing dramatic, nothing loud. Just another visitor passing through the inner solar system, following a path written by gravity and time. A normal pass. A normal perihelion approach. Another dot of light among millions. At least, that's what everyone believes. The object doesn't glow. It doesn't flare. It doesn't announce itself. It just slides through the dark, steady, and obedient. Telescopes track it the way they've tracked thousands before. Coordinates are logged. Positions confirmed. The data flows in quietly, almost boring in its predictability. This is how discovery usually feels at first, uneventful. Somewhere inside a control room, a screen updates, numbers refresh, a graph redraws itself. The light curve begins to form, just a simple rise and fall, the brightness of an object measured over time as it reflects sunlight back toward Earth. This is routine. So routine that no one is really watching closely. Until someone is. At first, it looks like a glitch. The brightness doesn't dip where it should. Instead of smoothing out, the curve bends sharply. Too sharply. It pauses. Then it rises again. That's odd. The astronomer blinks. Leans closer. Scrolls back through the data. Checks the timestamp. Maybe the telescope shifted. Maybe a calibration error. Maybe a passing star crossed the frame. These things happen, so the data is cleaned, filters applied, noise removed. The curve redraws, and it's still wrong. The object is brightening, but not smoothly, not naturally. The change comes in steps, like someone turning a dial instead of sliding it. That's when the room gets quieter. No one says anything yet, because in science, you don't jump to conclusions. You question your tools before you question the universe, so they check again. Another observatory runs the same observation. Different instruments. Different sky, different night. The result comes back, the same curve, the same strange bend, the same refusal to behave. Now, it's not a glitch. It's an anomaly. The object is still far from the sun, still approaching perihelion, still expected to act like every other cold body that's ever made this journey, but it isn't. Its light curve doesn't follow a clean arc. It pulses, softly, subtly, but with intention. Bright, pause, brighter, pause, like hesitation, like waiting. Astronomers begin pulling old models off the shelf. They overlay predicted behavior with real data. They zoom in, zoom out, adjust scales. The mismatch grows clearer the longer they look. This shouldn't be happening. That sentence hangs in the air, unspoken, but shared. Because light curves are simple, they're one of the first things you learn to trust. They tell you about shape, rotation, surface, dust. They don't lie. So when one lies or seems to, it shakes something deeper. Emails are sent, screenshots shared. Late-night messages begin to bounce between time zones. Are you seeing this too? Check the spike at this timestamp. Could this be an error in our reduction? But the more eyes that look, the worse it gets. The curve isn't random, it's patterned. Not perfectly regular, but close enough to feel deliberate. The kind of pattern your brain keeps circling back to, even when you try to ignore it. Someone suggests the object might be tumbling unusually fast. Another says maybe it has an uneven surface. Ice mixed with metal, reflecting light in strange ways. Both explanations sound reasonable. Both fall apart under closer inspection, because tumbling creates chaos in a light curve. This is controlled. The object isn't spinning wildly. It's behaving too well. And suddenly, a quiet thought slips into the room. What if the problem isn't the data? What if the problem is expectation? For decades, astronomers have learned what normal looks like. Comets brighten as ice vaporizes. Asteroids reflect steadily. Heat follows distance. Light follows geometry. Rules. Comforting rules. But this object doesn't seem interested in them. As it drifts closer to the sun, its brightness doesn't just respond, it anticipates. The change begins before the distance should matter, as if the object knows what's coming, as if it's not just reacting, but adjusting. That's when the waiting begins. Not just the waiting of the sky, the waiting of people. Observatories schedule more time. Tracking priority quietly increases. Nothing public yet. No announcements. No headlines. Just eyes watching. Every new data point feels heavier than the last. Every update carries the same question, pressing harder each time. Why this shape? Why now? Why here? And beneath all of it, another question. One no one wants to say out loud. What if discovery isn't about finding something new, but realizing we've misunderstood something old? The object continues its slow approach, silent and indifferent to the attention it's drawing. It doesn't flash dramatically. It doesn't change course. It simply keeps moving, while its light curve keeps whispering that something is off. Something subtle, something patient, something waiting. And as the sun grows larger in its path, one thing becomes clear to everyone watching the sky that night. This isn't the moment of answers. It's the moment before them. Because when discovery begins with a mistake, you have to ask yourself, what else have we been reading wrong all this time? The first sign that something is wrong doesn't arrive with drama. It arrives quietly. A small rise where there should be a fall. On a screen filled with curves and lines, the brightness ticks upward instead of down. Just a little. Easy to miss. Easy to explain away. At first. Because in space, brightness follows rules. As an object moves, light fades or grows in smooth, expected ways. There's comfort in that. Order. Predictability. This doesn't follow that order. The graph flattens. Not slowly, not naturally. Just stops changing. Like it hit an invisible wall. The room doesn't react right away. No alarms. No sharp breaths. Just a pause. Someone leans back in their chair. Someone else leans forward. Eyes narrow. Run it again. The data is pulled fresh from the telescope. Same time window, same filters, same calibration. The numbers update. The curve redraws itself, and it's still wrong. Brightness rises again, slightly higher this time, then locks into the same flat shape. No decay. No noise, no scatter. A clean, unnatural line. That's when the silence starts to feel heavy. Because errors usually look messy. They spike. They wobble. They scream that something broke. This doesn't scream. So the scientists do what they always do next. They doubt themselves. They check the instrument temperature, the mirrors, the sensors, the software version, every tiny thing that could nudge a measurement off by a fraction. Nothing stands out. So they widen the net. Data from another night is pulled in. Then another. Different angles, different lighting, different background stars. Same result. The object brightens where it should dim, then settles into a plateau that refuses to explain itself. At this point, curiosity turns into unease, because the anomaly isn't drifting, it's persistent. Someone overlays older models, decades of comet and asteroid behavior mapped into neat expectations. The comparison is brutal. The new line doesn't match any of them, not even close. The brightness doesn't roll over like melting ice. It doesn't flicker like dust jets. It doesn't stutter like tumbling rock. It behaves like something being managed carefully. That thought isn't spoken out loud. Not yet. Because there are still safer explanations. Stranger materials, unknown surface layers, exotic rotation. So those ideas are tested. Simulations run through the night. Virtual versions of the objects spin and heat and cool under simulated sunlight. None of them flatten the curve like this. None of them rise, then stop, then rise again later at nearly the same rate. The anomaly has rhythm now. Not a perfect one, but close enough to notice. A scientist scribbles notes in the margin of a printout. Another taps a pencil against the desk without realizing it. Something about this feels intentional, and that's dangerous, because the moment you start thinking that way, you risk seeing patterns when none exist. So they resist it. They triple-check. The data is sent to a third observatory. Independent reduction. Independent analysis. The response comes back hours later. Same curve, same flatness, same wrongness. That's when doubt stops being private. Emails start flying. Screenshots get circled in red. The anomaly gets a name. Not poetic, just practical. The brightness plateau. But even the name feels like a placeholder. Like a label slapped onto something no one understands yet. As the object continues its slow journey inward, the plateau repeats. Each time the brightness should drop, it hesitates. Each time it should smooth out, it locks into that same unnatural calm. The sky isn't flickering, it's holding its breath. Someone asks the question everyone's thinking, but says it carefully. Could we be seeing an effect of observation itself? No one answers right away. Because that question cuts deep. It suggests the object might not just be reflecting light, but responding to it. That idea doesn't belong in early-stage analysis. It's too big, too strange, too close to science fiction. So it's pushed aside, for now. But it doesn't leave, because the anomaly isn't going away. Each new dataset makes it clearer. The brightness changes arrive in steps, not curves, as if thresholds are being crossed, as if conditions are being met, as if something is waiting for the right moment. And that's when another, uncomfortable thought creeps in. What if this isn't new behavior? What if we've seen it before and just never noticed? Old archives are searched. Faint objects. Poor resolution. Early surveys with limited precision. There are hints, just hints. A few odd curves here and there. Dismissed as noise. Buried in old reports. No one went looking because no one expected this. The anomaly doesn't announce itself loudly. It doesn't break the sky. It whispers. And whispers are easy to ignore until they repeat. The object continues to glide along its path, unchanged in direction, unchanged in speed. Nothing dramatic, nothing threatening, just a quiet refusal to behave. And that might be the most unsettling part of all, because if something were truly wrong, we'd expect chaos, instability, escalation. Instead, we get control. The brightness stays exactly where it wants to be, as if the sky itself is saying, "This is on purpose." No one writes that in a report. But everyone feels it. Late at night, alone with the screens, scientists stare at the same flat line and feel a strange mix of wonder and doubt. Wonder because the universe still knows how to surprise us. Doubt because this surprise feels different. It doesn't feel like chance. It feels like choice. And as the object drifts closer to the sun, the anomaly remains locked in place, calm and steady against rising radiation and growing attention. The sky isn't correcting itself. It's insisting that something here doesn't fit the story we've been telling ourselves. So the question changes. It's no longer, is the data wrong? It becomes something far more unsettling. Is the sky showing us something new? Or revealing something we were never meant to see yet? The anomaly holds, and whatever comes next is already on its way. At first, no one calls it a pulse, because pulses mean intention. And space is not supposed to have intention. It begins as a faint wobble buried inside the signal. A tiny rise. A tiny fall, so small it could be dismissed as noise, the kind of thing astronomers have learned to ignore after a lifetime of staring at imperfect data. Space is messy. Telescopes aren't perfect. Signals breathe, so they let it pass. But the wobble comes back. Same shape, same spacing, again and again and again. That's when someone zooms in and the room gets quiet. Because when the timeline stretches across the screen, the fluctuation isn't random anymore. It's spaced. Evenly, calmly, like a heartbeat. Not fast, not urgent, just steady. One pulse, pause, another pulse, pause. Seconds apart. Measured, controlled. That's when the word noise starts to feel dishonest. Noise doesn't repeat like this. Noise doesn't respect time. So they isolate the signal. They strip away background radiation. They subtract stars, dust, cosmic interference. Everything that might be contaminating the data. The pulse survives. Still there, still ticking. Someone suggests it could be a rotating surface, light flashing as the object turns. It's a reasonable idea, until the math is done. The rotation rate would have to change, then change back, then lock itself into perfect timing. That doesn't happen by accident. Another explanation is offered. Thermal flicker. Small vents opening and closing as heat builds up under the surface. Again, reasonable, until the pulses keep perfect time across different wavelengths. Visible light, infrared, reflected sunlight, all pulsing together. That's not heat escaping, that's coordination. Now the tension shifts, because this isn't one telescope anymore. Data from another observatory is pulled in, then another. Different continents, different skies, different instruments. The pulse appears everywhere. Same spacing, same rhythm. Same silence between beats. That's when the realization lands, heavy and slow. This isn't local. It's the object isn't flickering differently depending on who's watching. It's doing the same thing for everyone. As if it doesn't care who sees it. As if it expects to be seen. People stop leaning back in their chairs. They lean forward now, elbows on desks, faces close to screens. Someone whispers, "Measure the timing again." They do, milliseconds, seconds, minutes. The spacing doesn't drift, no jitter, no decay. Just pulse, pause, pulse, pause. The universe is full of cycles, orbits, rotations, waves, but cycles wobble. This doesn't. This holds time like a metronome, and the question slips out, barely louder than a breath. Since when does space keep a beat? No one answers, because no one has a good one. The pulse doesn't carry information. There's no obvious message, no rising complexity, no pattern inside the pattern. It's simple, almost too simple, which somehow makes it worse. Because complexity can be chaos. Simplicity feels deliberate. The pulses continue night after night as the object inches closer to the sun. Solar interference grows stronger. Radiation noise increases. The pulse doesn't care. It cuts through everything, unchanged, as if it's anchored to something deeper than light. At this point, the phenomenon gets a name. Not poetic, not dramatic, just practical. Periodic brightness modulation. But no one uses that name when they talk in private. They call it the beat. Late-night conversations start to sound different now. Less technical, more careful. People stop saying probably and start saying, what if? What if the object isn't just reflecting light? What if it's modulating it? What if the brightness isn't a side effect? What if it's the point? That thought is dangerous, so it's pushed down, because history has taught scientists what happens when you leap too far ahead of the data. You lose credibility. You lose trust. So they stay disciplined. They ask safer questions. Could solar-wind interactions cause periodic changes? Could magnetic fields be involved? They test those ideas. They fail. Magnetic interactions would smear the signal. Solar wind would distort the timing. This pulse stays clean, almost respectful. And then something else happens. The pulse synchronizes. At first, different wavelengths peak slightly apart, barely noticeable, a few milliseconds. Then they align perfectly. Visible, infrared, reflected spectra, all peaking together like a single breath. That's when someone finally says it out loud. I don't think this is natural. The room doesn't react with shock. No gasps. No arguments, just stillness, because deep down, everyone already felt it. The pulse doesn't speed up as the object heats. It doesn't slow down as conditions change. It stays the same, as if time around it doesn't matter, as if the pulse is set, and nothing outside is allowed to touch it. That's not how space behaves. Space reacts. Space deforms. Space is messy. This is not. The object continues its journey in silence, but the beat never stops. It doesn't announce itself louder. It doesn't escalate. It simply continues, patient and precise. Like it's not trying to impress anyone. Like it's waiting. And that may be the most unsettling part, because signals meant to be noticed tend to grow stronger. This one doesn't. It just exists, steady, unbothered, as if it's been doing this for a very long time, and will keep doing it long after we stop watching. Somewhere between awe and fear, a quiet understanding begins to form. This isn't a flare. It isn't a glitch. It isn't a dying object crying out. It's a presence, measured, calm, controlled, a rhythm placed into the dark. And as scientists continue to track the pulse, one thought lingers, soft, unavoidable, impossible to unhear. If this beat exists without purpose, then why does it feel like it's counting something? And if it does have a purpose, who or what set the tempo? The pulse continues, unanswered, waiting, and whatever comes next will not arrive quietly. As the object drifts closer to the sun, something else begins to change. Not its speed, not its path, but the way it touches light. At first, the shift is subtle, almost polite. Easy to miss unless you're already looking too closely, which they are. Because once you've seen a pulse where none should exist, you don't stop watching. The sun grows larger in the object's sky. Radiation increases. Photons slam into its surface harder, faster, more often. This is where things usually get messy. Ice boils. Dust explodes outward. A soft cloud forms, scattering light in wild, uneven ways. Brightness rises and falls in smooth, messy gradients. That's the rule. But this object doesn't follow it. Instead of a slow change, reflectivity jumps, not gradually. Suddenly, one moment the surface reflects a certain amount of light. The next, it reflects more, cleanly, sharply, like a switch being flipped. Then it holds. No decay, no flutter, just a new level, locked in place. Someone blinks, checks the scale, zooms out, zooms back in. The jump is still there. A step, then another. As the distance to the sun shrinks, the reflectivity doesn't rise smoothly. It climbs in clear stages, plateaus separated by abrupt shifts. Step, hold, step, hold. That's when the dust models are pulled up, because dust explains almost everything in space. It's the universal excuse, the cosmic shrug. Dust scatters light. Dust brightens objects unevenly. Dust hides complexity behind chaos. But dust doesn't behave like this. Dust blooms. Dust fades. Dust is sloppy. This isn't sloppy. There's no surrounding haze, no expanding cloud, no trail thick enough to explain the sudden jumps. The object stays sharp, defined, contained, as if nothing is escaping from it at all. That realization lands slowly. Because if there's no dust, then the light isn't being scattered, it's being reflected directly off a surface. And surfaces don't usually act like this. Rocks warm gradually. Ice darkens as it melts. Metals heat unevenly. They don't jump between states. Unless someone pulls up material response charts. Exotic ices. Crystalline structures. Layered compounds formed in deep space. Some of them show thresholds, points where behavior changes rapidly. But none of them repeat this cleanly. None of them reset and repeat again under similar conditions. This object does. As it approaches another invisible boundary, another level of solar intensity, the reflectivity shifts again. Same size jump, same timing relative to distance. Same calm. It's not reacting wildly to the sun. It's responding selectively. That's when the metaphor appears in someone's mind, uninvited. A mirror with settings. The thought feels ridiculous, almost embarrassing, so it's ignored. For about 30 seconds, then the next dataset arrives. Another step, another hold, perfectly aligned with the last. At this point, frustration creeps in, not fear yet, just irritation. Because nature usually gives you something to hold on to. A mess, a clue, a mistake. This gives nothing. It just changes and dares you to explain why. Someone suggests surface restructuring. Maybe the outer layer rearranges itself as heat increases, exposing different materials beneath. It's a clever idea, until you realize restructuring takes time. This doesn't. The change happens faster than thermal diffusion allows, faster than cracking, faster than melting and refreezing. It's too fast, like the surface was already prepared, waiting for the right trigger. The sun crosses another threshold. The reflectivity jumps again, not randomly, predictably. Now the unease deepens, because prediction is dangerous territory. It means the behavior can be anticipated, even if it's not understood. And that makes it feel less like a mystery and more like a system. The object doesn't glow brighter in response to chaos. It doesn't flare. It doesn't shed material. It adjusts as if it's maintaining something, as if reflectivity isn't a side effect, but a setting. A few scientists start quietly comparing notes with the pulse data, timing, spacing, correlations. The steps in reflectivity line up disturbingly well with changes in the pulse amplitude. Not perfectly, but close enough to notice. Light in, response out. Light increases, surface adapts. No dust, no debris, no mess, just clean transitions. That's when the question forms. Slowly, carefully. What kind of surface reacts like a switch? No one answers, because nothing in known astronomy does. Switches imply states. States imply control. And control implies design. That's too far, so they pull back. They double-check geometry, viewing angle, phase effects. Could the change just be how we're seeing it? The math says no. The sun object Earth angle doesn't shift enough to explain the jumps. They try one last refuge. Coincidence. Maybe the steps only look sharp because of data resolution. Maybe with better sampling, they'd smooth out. So they increase sampling. Higher cadence. Faster measurements. The steps get sharper, clearer, undeniable. The reflectivity isn't smoothing with better data. It's snapping. And suddenly, something becomes painfully obvious. The object isn't just interacting with sunlight, it's managing it. Absorbing when it wants to, reflecting when it chooses. As if it's protecting something beneath the surface, or maintaining a condition inside. That thought sends a chill through the room, because comets don't protect themselves. Asteroids don't manage heat. Dead objects don't optimize. But systems do. Machines do. No one says that word out loud. Not yet, because the data still isn't shouting. It's whispering. And whispers are easier to dismiss. Still, the sun keeps approaching, and the object keeps stepping through its invisible thresholds, calm and unbothered. Reflectivity jumps, holds, waits, like it's listening for something only it can hear. And as the surface continues to react with impossible precision, one truth settles in quietly. This object is not being changed by the sun. It is changing itself. in response to it, which raises a far more unsettling thought. If the surface can switch states, what else can? And if this is only the outside, what's happening beneath it? The reflectivity locks into its latest level. The pulse continues. The sun burns closer. And somewhere between light and silence, the object reveals just enough to make one thing clear. Whatever this is, it was built to endure what's coming. And we are only beginning to understand why. Heat is supposed to be honest. You move closer to the sun. You get warmer. You move away. You cool down. It's one of the simplest rules in space. So simple that no one questions it. No one expects it to fail until it does. The first thermal readings arrive quietly, mixed in with everything else, just numbers, just colors on a screen. Reds and blues shifting as the object continues its slow fall inward. At first, it looks normal. The temperature rises steadily, calmly, exactly as expected. Then it doesn't. The heat spikes, not gradually, not smoothly. It jumps. A sudden surge in temperature, sharp enough to catch attention, brief enough to raise questions. Then it drops. Back down. Too fast, like someone turned something off. A scientist frowns. Scrolls back, rechecks the timestamp. Maybe the instrument glitched. Maybe solar interference caused a false reading. These things happen. So the data is cleaned. The spike stays. Then it happens again. Another thermal rise. Another sudden fall. Same spacing, same shape. A pattern. And patterns are dangerous. Because patterns don't belong to random heat. Heat is chaotic. It spreads. It lingers. It bleeds into everything around it. This doesn't. The temperature increases, peaks, then collapses. Clean and controlled, like a breath being taken and released. Someone overlays the distance to sun curve. They shouldn't match perfectly. But they almost do. Almost. Close enough to be unsettling. The spikes don't align with closest approach moments. They don't follow solar flares. They don't match rotation models. They happen when they happen, as if triggered by something else entirely. That's when the room starts to feel warmer, not from the data, but from the tension, because thermal behavior is hard to fake. Light can trick you. Dust can confuse you. Geometry can lie. Heat doesn't. Temperature tells you what energy is doing, where it's going, how long it stays. And right now, energy is misbehaving. The object heats up quickly, then cools faster than physics allows. That shouldn't be possible. Unless heat is being redirected. Unless it's being absorbed, then removed. The idea sits there, uncomfortable. Someone suggests internal shadowing. Maybe cavities inside the object are opening and closing, changing how heat spreads. It's a clever thought, until the cooling rate is calculated. It's too fast, too clean. There's no gradual bleed-off, no thermal tail, no lingering warmth. The heat vanishes, not into space, just gone, as if it never belonged there in the first place. Now the thermal spikes start to line up with other data. The pulse, the reflectivity steps. The moments of heat absorption happen just before reflectivity shifts, and just after, pulse changes. Not perfectly, but close enough to notice. Too close. That's when someone says something no one likes to hear. It looks like it's choosing when to heat up. The words hang in the air. Choosing. That's not a scientific term. It doesn't belong in reports, or graphs, or peer review. But it belongs here, because nothing else fits. The sun doesn't pulse like this. Solar radiation doesn't turn on and off. If the object were passive, heat would soak in steadily, then slowly escape. Instead, it arrives, stays briefly, then disappears. Over and over, like a system testing limits. Absorb, pause, release. Absorb, pause, release. Almost like breathing. The object isn't overheating. It isn't breaking apart. It isn't venting material. It's managing thermal stress, protecting itself. That realization changes everything. Because thermal management is hard. It requires structure, planning, feedback. Dead rocks don't manage heat. They suffer it. But this object doesn't suffer. It responds. Someone pulls up spacecraft data. Heat shields, radiators, thermal control systems used by probes and satellites. The resemblance is uncomfortable. Those systems absorb heat during peak exposure, then shed it deliberately to avoid damage. That's exactly what this looks like, except this object wasn't built by us, at least not that we know of. So the team steps back again. They ask the safest question left. Could this be an extreme natural case? An object with layers of unusual materials, phase change compounds, exotic internal structures. The models strain. They stretch physics until it groans. Some combinations get close, but none repeat the pattern this cleanly. None reset again and again without degradation. Natural systems wear down. This doesn't. Each thermal cycle looks as clean as the first. That's when the fear creeps in. Not panic, not terror, but something colder. Respect. Because whatever this object is, it's prepared. Prepared for heat. Prepared for stress. Prepared for the sun. As it draws closer to perihelion, solar intensity increases sharply. This is where most objects struggle, where surfaces crack, where volatile materials explode outward. This one doesn't explode. It adapts. The thermal spikes grow slightly stronger, but shorter. The cooling becomes even faster. Efficiency improves. That's not what erosion looks like. That's optimization. The room goes quiet again. Not because people don't have theories, but because every theory now points in the same uncomfortable direction. This object isn't just reacting to its environment, it's regulating itself within it. And regulation implies a goal: to survive, to endure, to remain intact. No one says machine. No one needs to. The word floats there anyway, unspoken, heavy, because machines are designed to manage energy. Machines decide when to absorb heat and when to release it. Machines don't panic under stress. They adjust. Outside, the sun burns like it always has. Blind, indifferent, powerful. Inside the data, something is pushing back. Quietly, elegantly. The thermal pattern repeats again. Spike, drop, hold. The object continues its approach, untouched by forces that should be tearing it apart. And suddenly, a thought becomes impossible to avoid. If it can choose when to absorb heat, what else can it choose? When to reflect light? When to pulse? When to stay silent? The object isn't screaming for attention. It isn't hiding either. It's existing on its own terms. And as the sun looms closer and the thermal behavior remains controlled, one unsettling truth settles in. This object understands its environment far better than we understand it. It knows the sun. It knows heat. It knows thresholds. And whatever purpose it serves, it was built to survive this moment. The temperature stabilizes. The pulse continues. The reflectivity holds. And the question that now follows every data update is no longer scientific, it's personal. If this object can choose how it handles the sun, what happens when it has to choose how to handle us? The heat fades. The mystery deepens. And whatever comes next won't be explained by physics alone. The silence doesn't arrive slowly. It arrives all at once. One moment, the pulse is there, steady, patient, familiar in its own unsettling way. A rhythm that has followed the object night after night, cutting through noise, holding time like a promise. And then, nothing. No fade. No warning. No final beat. Just a flat line where the rhythm used to be. At first, no one believes it. Someone refreshes the screen. Someone else checks the timestamp. Another pulls the raw feed, convinced the software froze or a setting changed. Because signals don't just stop. Not cleanly. Not like this. The data updates again. Still nothing. The pulse is gone. The room fills with a strange energy. Not panic, not relief, but confusion sharpened into disbelief. Chairs scrape softly, screens multiply, windows open and close. Someone whispers, "Check the last cycle." They do. The final pulse looks exactly like all the others. Same strength, same spacing, same calm. No decay, no weakening, no hint it was about to end. It didn't die. It ended. That difference matters. Because natural signals fade. They stretch. They stumble before disappearing. This didn't stumble. It stopped, as if a switch was flipped. The irony is almost cruel. For days now, teams have been preparing to speak. Careful language, neutral phrases, charts designed to explain without alarming. A public update is coming. Not dramatic, just cautious transparency. We've observed unusual periodic variations. That was the plan. But now there's nothing to show. The pulse that sparked the questions is gone. Across the world, observatories scramble to confirm it isn't local. Instruments are recalibrated, backup systems activated, independent feeds cross-checked. The silence holds. Same object, same position, same distance from the sun, different behavior. The brightness curve continues its stepped pattern. The thermal cycles still appear. The reflectivity remains locked. Everything else is still strange. Only the pulse, the beat, is missing. That absence feels louder than anything that came before. Because silence isn't empty. Silence is a state. Someone finally says it, voice low. If it were noise, it wouldn't stop like this. No one argues. If it were rotation, it would continue. If it were heat, it would fluctuate. If it were interference, it would drift. But this silence is perfect, unbroken. As if the object decided, enough. That's when the room changes. Before, there was tension mixed with curiosity. Now there's something else layered on top, vulnerability. Because when a strange signal appears, you can study it. You can measure it. You can pretend it belongs to the universe, not to you. But when it disappears, right as you're getting ready to talk about it, it feels personal. Someone suggests a temporary obstruction. Solar noise masking the signal. A change in viewing angle. The math doesn't support it. The geometry hasn't shifted enough. The sun isn't flaring. The background remains stable. The pulse should be there. It simply isn't. Minutes stretch into hours, hours into days. The silence remains absolute. And slowly, an uncomfortable realization begins to form. The object didn't lose the ability to pulse. It lost the need. Or worse, it noticed it was being noticed. That thought isn't scientific. It doesn't belong in analysis. But it refuses to leave. Because timing matters. The pulse doesn't stop early, when the object is distant and ignored. It doesn't stop late after perihelion stress. It stops now. At the exact moment attention peaks. At the exact moment explanations are being prepared. At the exact moment the story is about to leave the lab and enter the world. That coincidence is hard to swallow. Someone pulls up the full timeline. Discovery, anomalies, pulse onset, reflectivity shifts, thermal control, then the stop. It looks like chapters, like phases, like something moving from one state to another. And suddenly, the silence isn't empty anymore. It's full of implication. Phones buzz with messages from colleagues. Are you seeing this too? Yes. Still gone? Completely. No one uses the word signal now. They say activity. They say behavior. Careful words. Because a signal implies sender and receiver. And no one is ready for that conversation. Behind closed doors, discussions grow quieter, less speculative, more cautious. What do you say publicly when the strangest feature simply vanishes? How do you explain absence without sounding like you're hiding something? In the end, the statement is delayed, not cancelled, delayed. Because silence is harder to explain than noise. The object continues its path, indifferent to our confusion. It doesn't replace the pulse with something else. It doesn't escalate, it just goes quiet, as if the experiment is over, as if the test phase has ended. That thought settles heavily, because tests end for a reason. Either the conditions were met, or they weren't. Late at night, alone with the screens, some scientists replay the early data, the first pulse, the early anomalies. They listen to the rhythm that no longer exists. And for the first time, a truly unsettling question feels unavoidable. Was the pulse ever meant to be understood? Or was it only meant to be noticed? The silence doesn't answer. It just stretches on. Clean. Controlled. Absolute. And in that silence, a line is crossed. Before, the mystery was about behavior. Now, it's about intent, because something that can produce a signal and then remove it without a trace isn't just reacting to space. It's making choices within it. The object drifts closer to the sun, unchanged by the absence of its own rhythm. It doesn't seem diminished. If anything, it seems resolved. And that raises a final, chilling thought. One no one wants to say out loud, but everyone feels. If the signal was turned off, what was it for in the first place? And if it can choose silence, what happens when it chooses something else? The screens stay flat. The sky stays quiet. And for the first time since this began, humanity isn't listening to a mystery anymore. It's waiting for one to speak again, in its own time, on its own terms. The question doesn't arrive loudly. It slips in sideways, between sentences, between caution and curiosity, between what the data says and what it suggests. No one stands up and declares anything bold. No one rushes to microphones. No headlines are written. Instead, the language begins to change, just slightly. In meetings, words slow down, sentences grow longer. People stop finishing each other's thoughts. Someone says, "If this were artificial," then quickly adds, "I'm not saying it is." Another says, "There appears to be a level of control," then clears their throat, changes the subject. No claims, no conclusions, just questions, carefully placed, softly spoken. But once the words are out, they don't go back in. Artificial control. Those are dangerous words in science. They carry weight, history, consequences. They can end careers if spoken too boldly, too soon. So they're handled like glass, because up until now, everything strange could still be explained away as extreme nature. Rare materials, unusual geometry, a once-in-a-lifetime object doing once-in-a-lifetime things. Unlikely, but possible. This question is different, because it doesn't ask how the object behaves. It asks why, and why is where science gets uncomfortable. The evidence is laid out again. Not dramatically, methodically, the pulse that held perfect time, then stopped instantly. The reflectivity that shifted in clean steps. The thermal spikes that appeared and vanished on command. Each piece alone is strange. Together, they begin to feel coordinated, not random, not accidental. Someone points this out, gently. These behaviors seem optimized. The word hangs there. Optimized. Not eroded. Not degraded. Not chaotic. Optimized implies efficiency, purpose, feedback. Systems that optimize don't just exist, they function. And that's when the conversation changes tone. No one is talking about aliens. Not even close. They're talking about systems, about mechanisms, about the possibility, however remote, that the object is not purely passive, that it might be regulating itself, responding to conditions, managing exposure. Another researcher pushes back. Nature does that too, and they're right. Cells regulate, stars self-balance, planets settle into stable states, but those processes are noisy, slow, imprecise. This isn't. This is clean, discrete, repeatable. Someone brings up the reflectivity steps again, the sharp transitions, the lack of dust, the absence of debris. If this were erosion, they say, we'd see loss. But we don't. We see preservation. The room goes quiet, because preservation suggests foresight. The question sharpens, not louder, but clearer. What if this object isn't just surviving space? What if it was built to move through it? That idea is still too far. So the framing changes again. What if, someone says slowly, it's artificial in the same way a dam is artificial? Not intelligent, not alive, just designed. A structure built for a purpose. The metaphor lands. Because dams don't think. They don't decide. They respond to pressure the way they were meant to. They control flow. And suddenly, the data looks different through that lens. The pulse becomes regulation. The heat spikes become thermal management. The reflectivity steps become shielding adjustments. Nothing conscious, just function. That distinction matters. It gives everyone a little room to breathe. But even that softened version carries weight. Because if something artificial is moving through our solar system, then it didn't form here. It was placed, or sent, or drifted in long ago. built somewhere else. The conversation slows even more. Every word now feels like it might echo. Someone asks the question everyone is avoiding. If it's artificial, what's its purpose? No, one answers, because purpose is where speculation explodes. Communication, exploration, survival, all too big, all too fragile. So they back up. They ask a smaller question. Does it behave like a natural object? And for the first time since this began, the honest answer feels like no. Not entirely. Not anymore. The silence after the pulse looms large now. It's reinterpreted in this new light. Before, it was a mystery. Now, it feels like a decision. Not proof, just context. If the pulse were accidental, it would have no reason to stop cleanly. If it were functional, it might, especially if its job was done. That thought sends a quiet chill through the room, because job implies intent, even if not conscious intent. Someone tries to ground the discussion. We need to be careful, they say. History is full of people projecting meaning onto the unknown. Everyone agrees. But history is also full of moments where meaning was there and ignored because it felt uncomfortable. The two truths sit side by side, and neither feels safe. The word machine is never spoken openly, but it's there, in the pauses, in the careful phrasing, in the way people now say the object instead of the body. Machines don't have to be intelligent to be unsettling. They just have to work. Late at night, alone, some researchers replay the data again, not to analyze, but to feel the precision, the restraint, the lack of waste. This isn't a dying thing. This isn't a random thing. It's a thing doing exactly what it's meant to do. Nothing more, nothing less. And that's what makes the question impossible to ignore. Because once you allow the possibility of artificiality, even as a thought experiment, the universe changes shape. Suddenly, space isn't just a place where things happen. It's a place where things move through, built things, designed things. Things that don't announce themselves with noise or fire, but with restraint. And restraint is hard to unsee. The researchers don't publish anything bold. No papers claim design. No press releases use dangerous words. But the internal language has shifted. Carefully, irreversibly. The question has been asked. And questions, unlike signals, don't stop when you want them to. They spread. They echo. They wait. As the object continues its journey, silent and composed, the machine question lingers like a shadow just outside the light. Not a belief. Not a conclusion. Just a possibility. But once a possibility like that enters the room, it never really leaves, because from this point on, every new behavior will be measured against it. Every silence will feel intentional. Every adjustment will feel deliberate. And the most unsettling part isn't that the object might be artificial. It's that asking the question has changed us. Because now we're not just watching space anymore. We're wondering, for the first time, whether something out there was built. Justice. And whether we were ever meant to notice it at all. The reaction doesn't explode all at once. It fractures, slowly, unevenly, across screens, studios and quiet rooms where people scroll long after midnight. At first, it's curiosity. Headlines play it safe. Words like unusual, unexpected, rare, the kind of language that invites interest without demanding emotion. A strange object. Odd data. Scientists investigating. Nothing to fear. But curiosity doesn't stay calm for long, because the data is real. The graphs are real. The silence after the pulse is real. And once people realize that, interpretation begins to split. On one side, wonder, articles filled with awe, images of the cosmos painted as beautiful and mysterious. Commentators remind everyone how little we still know, how thrilling it is to be surprised. This is why we explore, they say. This is the universe reminding us to stay humble. On the other side, fear, less poetic, more urgent. Videos asking harder questions, posts dissecting timelines, amateur analysts slowing down clips, circling moments where the signal stopped. If it was natural, why did it stop? If it wasn't, why start at all? Those questions don't stay in comment sections. They move, they spread, and soon the story is no longer about an object. It's about meaning. Official statements begin to change tone. At first, they're confident. Pasha, calm, carefully worded. There is no evidence of threat. These observations are still under review. Extraordinary claims require extraordinary evidence. Familiar phrases, reassuring phrases, but reassurance has a weakness. It needs certainty, and certainty is exactly what no one has. Behind closed doors, briefings grow longer. Slides multiply. Footnotes pile up. Every statement is reviewed, then reviewed again. Not because the data is fake, but because the data doesn't explain itself. And that's dangerous, because when explanation lags behind observation, people fill the gap. Some fill it with imagination, some with dread, some with denial. The same graph means different things to different eyes. To one person, the stopped pulse is proof of a technical limit. To another, it's evidence of intention. To a third, it's a distraction from something bigger. The fracture deepens. Scientists are asked questions they can't answer yet. Was it a signal? Was it artificial? Did it stop because we noticed? They respond carefully. They talk about probability, about models, about patience. But patience doesn't trend. Emotion does. Clips circulate out of context. A pause in an interview becomes suspicion. A careful, "we don't know yet," becomes, "they're hiding something." That's when fear sharpens, not because of what the object might be, but because of what we might not be ready for. The truth is simple and uncomfortable. The universe doesn't owe us explanations. It never has. Stars explode without warning. Planets form without permission. Life itself began without an announcement. But this feels different, because for the first time, the mystery doesn't look chaotic. It looks restrained. And restraint feels intentional. Late-night talk shows make jokes. Daytime panels debate possibilities. Social media swings wildly between memes and meltdown. Two words begin to appear more often. Control, silence. And silence is the hardest part. Because there's no new signal to analyze. No fresh anomaly, just continuation. The object keeps moving. The sun keeps burning. The data keeps coming, minus the pulse. Nothing dramatic happens, and that lack of drama becomes its own kind of pressure. People want resolution. They want a reveal, a confirmation, a denial. Instead, they get waiting. Official channels urge calm. They stress that science moves slowly, that understanding takes time. They're right, but humans don't move slowly. We imagine faster than we analyze. And in that space between data and meaning, something fragile begins to tremble. Trust. Because when experts admit uncertainty, honestly, responsibly, it collides with a world trained to expect answers. The fracture widens. Some lean deeper into science, accepting the unknown as part of the journey. Others drift towards certainty wherever they can find it, even if that certainty is built on fear. The same truth sits at the center of it all. Something unusual is happening. No one disputes that anymore. The argument isn't about whether the data is real. It's about what the data means, and meaning is personal. To some, this moment feels like awakening, a reminder that we are small, and that the universe is vast and alive with possibility. To others, it feels like a warning, a crack in the story we tell ourselves about control and safety and understanding. Both reactions are human, both are valid, and both reveal something important. We are not reacting to the object. We are reacting to uncertainty, because uncertainty strips away comfort. It removes the illusion that someone, somewhere, always knows what's happening, and here no one does. The most honest sentence spoken in this entire story doesn't make headlines. It's said quietly in a meeting that will never be recorded. We may get answers, or we may not. That sentence changes the room, because it admits something we rarely say out loud. Truth does not always come with explanation. Sometimes the universe shows you a fact and leaves you alone with it. The object continues its path, indifferent to the noise we make below. It doesn't respond to headlines. It doesn't react to fear or wonder. It simply exists. And that might be the hardest truth of all. Because if something real can pass through our world, leave evidence, challenge our understanding, and then refuse to explain itself, then the question is no longer about the object, it's about us. Are we mature enough to live with unanswered truth? Are we capable of holding knowledge without certainty? Can we accept a reality where discovery doesn't come with closure? The media will keep debating. The experts will keep analyzing. The public will keep reacting. But somewhere beneath all of that noise, a quieter reckoning has already begun. This is what it feels like to reach the edge of understanding and realize there may not be a railing. The data is real. The mystery is real. And the explanation may never arrive. The object moves on. The conversation stays behind. And as humanity argues between wonder and fear, one silent question hangs over everything. If the universe offers us truth without explanation, are we ready to live with it? Perihelion is supposed to be the breaking point. It's the moment everything fragile comes apart. As an object dives closest to the sun, heat spikes. Radiation slams in. Surfaces crack. Ice explodes into gas. Tails stretch out like torn fabric. This is where comets scream. This is where weak things reveal themselves. So everyone watches closely as the object approaches that invisible line, the place where survival becomes a question. Screens glow late into the night. Models run faster. Predictions sharpen. Most of them say the same thing. It shouldn't make it through unchanged. Not after everything we've already seen. Not after the pulses. Not after the thermal control, not after the strange restraint. Perihelion arrives quietly. No flash, no flare, no final outburst, just proximity. The sun looms massive and unforgiving, filling the object's sky with fire and force. This is the closest it will come, the harshest test it will face. Data pours in, and for a moment, no one speaks, because nothing happens. No fragmentation, no sudden mass loss, no chaotic spike in brightness. The object doesn't scream. It doesn't even flinch. It passes perihelion intact, unchanged, as if the sun were just another condition it had already planned for. Someone scrolls back through the readings, convinced they've missed something. There has to be damage. There has to be erosion. There has to be some sign that the laws of stress and heat have taken their toll. There isn't. The reflectivity holds steady. The thermal behavior remains controlled. The structure stays coherent. The object emerges on the other side of perihelion, whole. That's when something breaks. Not the object. The models, equations that have worked for decades, suddenly feel thin. Assumptions that once felt solid begin to wobble. Because these models aren't guesses, they're built on countless observations, on thousands of objects that didn't survive this close. Nature has always been consistent here, until now. People rerun simulations, tweaking parameters, stretching values to their limits. They push materials to extremes. They imagine rare compositions, dense cores, protective crusts. Some models come close, none fully explain it. To survive perihelion like this, the object would need to dissipate heat faster than expected, shield itself more efficiently than known materials allow, and do it without shedding mass. That combination shouldn't exist. And yet, here it is. For the first time since this began, the tone shifts, not toward fear, but toward something deeper. Disbelief, because fear is easier when something looks threatening. This doesn't. It looks composed, and composure is unsettling. Someone says it quietly, almost to themselves. This thing doesn't behave like it's under attack. They're right. Most objects react violently to the sun's pressure. They vent, they fracture, they lose pieces of themselves just to stay together. This one doesn't lose anything. It behaves like it expected the heat. Like perihelion, wasn't a trial, but a checkpoint. That thought reframes everything. The anomalies no longer feel isolated. They feel connected. The pulse. The reflectivity shifts. The thermal regulation. All of it now looks like preparation. And preparation implies foresight. Not conscious foresight. Not awareness. Just design that anticipates stress. Nature can do incredible things. It can build structures that survive extreme pressure. It can balance forces in beautiful ways. But it usually leaves scars. This leaves none. The object moves away from the sun now, slowly climbing out of the deepest well of heat and radiation. If anything were damaged, this is when we'd see it. We don't. The readings stabilize. The behavior remains consistent. No delayed collapse. No hidden cost. It endured. That endurance changes the way people look at the data. Before, the question was, what is it doing? Now the question becomes, what is it? Because if this is natural, then our idea of natural is incomplete. Wildly incomplete. Maybe nature builds things tougher than we thought. Maybe there are processes we've never witnessed, working slowly over millions of years to create structures that can walk through fire untouched. That's possible. But if that's true, then the universe is far stranger and far more capable than we've ever imagined. And that realization is both humbling and destabilizing, because it means our models didn't fail because of a mistake. They failed because they weren't big enough. The object doesn't celebrate its survival. It doesn't change behavior. It doesn't announce anything. It just keeps going. And in that calm continuation, a shift happens, not in the sky, but in us. Up until now, the story was about anomalies. Now it's about limits. The limits of prediction. The limits of understanding. The limits of comfort. We like to believe that the universe is strange, but ultimately knowable. That with enough data, enough time, everything resolves into explanation. This moment challenges that belief. Because here is something that passed one of the harshest tests in the solar system without revealing its secret. No message, no breakdown. No confession, just survival. And survival, when it looks effortless, demands a new kind of respect. Somewhere in the back of the room, a thought settles in. Soft but heavy. If we had never seen the anomalies, if the pulse had never appeared, if the reflectivity hadn't stepped, we might have watched this object pass perihelion and called it remarkable, but not impossible. Context matters. And now the context is unavoidable. This object didn't just survive. It behaved exactly as something meant to survive would. That realization doesn't spark panic. It sparks humility, because it forces a simple admission. We don't understand this yet. And maybe we're not supposed to. The object continues outward, leaving the sun behind, carrying its secrets with it. It doesn't look back. It doesn't slow down. It remains what it has always been throughout this journey. Controlled, contained, unexplained. And as the data settles into a new normal, one quiet truth becomes clear. The universe didn't just surprise us. It reminded us that nature, or whatever wears its mask, does not owe us familiarity. If this object is natural, then nature is not gentle chaos. It is precise, prepared, capable of things we have not yet learned how to imagine. And that changes everything. Because from this point forward, every strange reading, every unexpected survival, every anomaly will be measured against this moment. The moment when something passed through fire and came out unchanged. The models fall silent. The object moves on. And our perception, once steady, once confident, has shifted, not broken, but widened. And in that widening, the mystery deepens. Because if this was only the test, what was it preparing for next? To understand where something is going, you first have to ask where it came from. That question sounds simple. It never is. After perihelion, as the object drifts outward, calm, intact, unchanged, attention slowly turns backward. Not emotionally, but mathematically. Lines are drawn, vectors reversed, time rewound. If we can't yet explain what it is, maybe we can understand where it began. So scientists trace its path back past the sun, back past the inner planets, back through the outer darkness where gravity loosens its grip. The calculations are clean, precise, unforgiving, and the further back they go, the stranger it gets. This isn't an object born in the familiar neighborhoods of our solar system. It didn't form with the planets. It didn't drift in from the Kuiper Belt. It didn't fall from the Oort cloud like countless long-period visitors before it. Its trajectory doesn't line up. The angles are wrong. The speed is wrong. Someone runs the numbers again, expecting them to settle into a known pattern. They don't. The object isn't just passing through our system, it's cutting across it. Its path is steep, tilted, uninterested in the flat disk where planets live and orbit. It doesn't hug the ecliptic like something raised here would. It arrives from above, from below, from somewhere off the map. The realization lands slowly, but when it does, it changes the room. This thing didn't grow up here. It's not a local. The more they trace the trajectory back, the more the familiar landmarks disappear. Gravity wells lose relevance. Stellar neighborhoods fade into uncertainty. Eventually, the math reaches a place where certainty ends. Interstellar space. Not nearby. Not recent. Deep. The object's inbound velocity suggests it wasn't gently nudged toward us. It wasn't captured. It wasn't wandering aimlessly. It was moving fast, too fast, as if it had been traveling for a very long time, without slowing down. Someone asks the question quietly, how long has it been out there? No one answers, because the honest answer is unsettling. Longer than our records, longer than our civilizations, possibly longer than our species. The object's path doesn't point back to any nearby star system. No clear origin, no obvious home. Instead, it points into a dense region of galactic space where stars are packed close and history stretches deep. A place we don't usually look, not because it's hidden, but because it's overwhelming. Too many stars, too much distance, too many possibilities. This isn't a breadcrumb trail. It's a fog, and that fog swallows easy stories. It would be comforting if the object came from somewhere obvious. A nearby star, a recent event, something that happened after us. But the math refuses that comfort. The timing doesn't line up with anything recent. No nearby supernova. No stellar flyby. No gravitational event that could have casually tossed something this precise, this intact, directly toward our sun. This wasn't an accident of chaos. At least, not one we can see. That's when the word origin starts to feel slippery, because origin implies a beginning we can point to. This doesn't give us one. The object didn't come from where we usually search for answers. It came from where we never expected to find questions. Someone pulls up simulations of interstellar travel. Not ships, not probes, but natural objects drifting between stars. Most of them tumble. Most of them erode. Most of them slow down or fragment long before they reach another system. This one didn't. It held course, held structure, held itself together across distances that shred lesser things. The implications are quiet, but heavy. Whatever shaped this object did so knowing it would travel far, very far. And travel is expensive in energy, in durability, in time. You don't build for travel unless travel matters. That thought sits uncomfortably in the background, because again, no one is claiming intention. Just compatibility. This object is compatible with deep time, compatible with deep space, compatible with environments that erase most things. As the trajectory is refined further, another detail emerges. The arrival timing. It didn't arrive randomly. Its path intersects our solar system at a moment when observation is possible. When our technology is advanced enough to notice, but still primitive enough to be confused. That coincidence is easy to ignore, but harder to forget. Someone suggests we might be overthinking it. That space is vast. That randomness given enough time, produces strange intersections. They're right, but randomness usually leaves fingerprints. This doesn't. The object doesn't wobble into our system. It enters cleanly, gracefully, like a needle threading a moving target. That doesn't mean it was aimed. But it does mean it was capable. And capability raises questions all by itself. As the object continues outward, the backward projections grow less certain. Errors widen. Possibilities multiply. Eventually, the trail dissolves into probabilities. Could it have passed near another star long ago? Possibly. Could it have wandered for millions of years before this encounter? Likely. Could it be older than Earth itself? There's no reason it couldn't be. That realization reframes everything. This object may not belong to our time. It may be a relic, a survivor from an era we've never seen, built or formed under conditions we don't understand, to do something we don't know, for reasons that may no longer exist. That's a strange comfort, because it means the mystery isn't about us. We're not the center of this story. We're just in its path. As the math settles into uncertainty, one thing becomes clear. We will not trace this object back to a familiar place. There will be no cosmic map with a circle and an arrow that says here. Its origin is not a dot. It's a direction, and that direction points outward, beyond our neighborhood, beyond our stories, beyond our expectations. The question shifts again. Not where did it come from, but what kind of universe produces something like this? A universe where objects can travel for eons without falling apart. A universe where structure can persist across star systems. A universe where not everything is born, lives and dies in one place. That idea is humbling, because it reminds us that space isn't just empty distance. It's a highway, and highways don't care who notices them. The object fades slowly as it moves farther away. Its behavior remains calm, its silence intact. It doesn't leave a trail pointing backward. It doesn't offer a clue. It simply continues towards somewhere else. And that leaves us with a question that no equation can answer. If this object wasn't shaped by our sun, wasn't born near our planets, wasn't meant for our understanding, then what sent it here? Was it chance? Was it time? Was it a process older than memory? Or was it something else entirely, moving patiently through the galaxy, indifferent to who happens to be watching when it passes by? We don't know. And that uncertainty doesn't feel like failure anymore. It feels like perspective. Because for the first time, we're not just looking at space as a place things come from. We're seeing it as a place things travel through. And that realization prepares us for something deeper. Because if the origin is unknowable, then maybe the destination matters more. The object keeps moving. The trail behind it fades. And as we stand at the edge of what can be traced, one quiet truth settles in. Whatever this is, it did not begin with us, and it will not end here. The mystery isn't where it came from. The mystery is why our path crossed its own, at all. The rule was simple. Get too close to the sun, and you pay the price. Everything we've ever watched obeyed that rule. Ice turned to vapor. Rock cracked. Objects screamed their presence in fire and debris before fading back into dust. That's how the story always ended. Until now. The sun did not destroy it, not slowly, not suddenly, not at all. The object passed through the furnace of our system and emerged the same way it entered, quiet, controlled, untouched. And then it gave us nothing. No message, no signal, no explanation, just silence. That silence is the hardest part, because we waited. After perihelion, I stayed locked on the data, half expecting something, anything, to happen. A delayed reaction, a final pulse, a sign that the universe would blink. It didn't. The object didn't celebrate its survival. It didn't acknowledge our attention. It didn't change course or behavior. It simply continued, as if passing our sun was never the point. That's when something deeper breaks, not in the sky, but in understanding. Because science is built on rules, patterns we trust, expectations that let us predict what comes next. And one of those rules was clear. Nothing fragile survives this intact. But this wasn't fragile. And if this rule no longer holds, then what else doesn't? The pattern remains unresolved. That phrase appears in reports, in quiet summaries, in carefully worded conclusions. Unresolved. It doesn't mean unsolved. It means something worse. It means there may be no clean answer waiting at the end. The pulse that once kept time never returns. The silence remains absolute. No decay, no echo, no after-image. It's as if the object said everything it was ever going to say, without saying anything at all. The anomalies don't collapse into one neat explanation. They don't align into a satisfying reveal. They just coexist. Pulse without message, heat without cause, survival without damage. Each one breaks a rule on its own. Together, they break a worldview. Some try to put the pieces back into familiar shapes. Extreme nature, rare materials, unknown physics waiting to be discovered. Those explanations might still be true. They might even be likely, but they don't feel complete anymore. Because completeness requires closure. And this story refuses to close. The object drifts farther away now, its data thinning as distance grows. Soon it will fade beyond our instruments, slipping back into the dark between stars. When that happens, nothing dramatic will mark its exit. No final anomaly, no cosmic punctuation, just absence. And absence has a way of lingering. Years from now, students will study this case. Researchers will reanalyze the data with better tools. Papers will argue back and forth over interpretations, but the feeling will remain. That moment when something passed through our system and didn't behave the way it was supposed to. That moment when the sun, our ultimate enforcer of cosmic rules, failed to break it. That changes how you look at the sky. Because if one object can ignore the rules, then the rules were never laws. They were habits. And habits can be broken. The universe suddenly feels less like a place of certainty and more like a place of capability. A place where things can be built or formed to endure conditions we once thought absolute. A place where silence can be intentional. A place where not everything that passes through wants to be understood. That realization settles slowly, uncomfortably. We are used to being observers, collectors of signals, interpreters of meaning. This time, we observed something that did not care to be interpreted. It didn't threaten us. It didn't greet us. It didn't even acknowledge us. And that may be the most unsettling truth of all, because it suggests a universe that doesn't revolve around reaction. A universe where objects can move through systems, test limits, survive stars, and move on. Indifferent. So the final question isn't about this object anymore. It's about context. If this passed through unnoticed for most of human history, if we only barely caught it now. If it followed rules we didn't know existed, then how many others have already passed by? How many objects are moving through the dark right now, built or shaped to survive suns, immune to expectations, silent by design? We look at the sky differently after this, not with fear, with awareness, because the dark doesn't feel empty anymore. It feels occupied. Not crowded, just not alone. The rule broke. The sun failed to destroy it. The object refused to answer us. And the pattern remains open-ended, like a sentence the universe chose not to finish. We don't know what it was. We don't know why it came. We don't know where it's going next. But we do know this. Something passed through our world, played by different rules, and left without explanation. And once you've seen that, you can never look at the night sky the same way again. Because somewhere out there, beyond our models, beyond our comfort, something else may already be watching. Not with eyes, not with intent, but with patience, moving quietly through the dark, waiting for nothing at all.